Hey there, welcome back our coders. It's enough napping because it's time to continue our journey into the world of Python. In this session, we'll dive deeper into the coolest programming language around and arm you with the insights you need to succeed. So put on your success hat and let's get started.
Good morning, everyone.
Good morning.
Good morning.
Morning.
Good morning.
Morning.
Okay, so let's start. What we discussed yesterday, we have started with the Python introduction. So we have some basic ideas. Why we are using Python language, why we are coding in Python. So we have started discussing few points where we have discussed about the platform independent and portability. So we need to to understand portability and platform independent, these two terms, we need the concept of translators, compilers, and interpreters. We have seen yesterday how compiler works and the whole code at once, where interpreter interprets the code line by line or instruction by instruction. We have seen there are two types of errors also in Python: compile time error and runtime error. So the diagram which we have seen yesterday, okay. So this is the way where the Python code executes. We have seen that Python translating the source code to the bytecode, and interpreter is executing the bytecode to give you the output. We have also discussed about the PVM. PVM is actually a set of software which comes with the PVM, stands for Python Virtual Machine. Right? So PVM stands for Python Virtual Machine, which has the interpreter in it, which this interpreter executes this bytecode line by line and it gives you the output. So this is about the execution sequence of the Python code. Okay. Now, so we have compiler and interpreter both. So what is the use of this compiler and interpreter? if you remember yesterday, we have discussed about how the C code getting executed. So we have the source code, we have compiler, and then it creates the executable code, which gives you the output, right? So we have only one compiler. So basically, we have divided this translation in two parts in case of Python. In case of Java, also you have these two parts, right? So what this compiler does here, it checks for the compile time error. This compile time error is checking the syntax error and let's say the indentation error. Okay, whereas this interpreter checks for the runtime error, name error, value error, type error. Okay. So we have these runtime error which checks for there are different types of runtime error which are checked by the interpreter. Okay. So can't we use only either compiler or interpreter? Yes, we can do that. We can just have compiler, like in C, we have the compiler which creates the executable code. That executable code will be equivalent to machine code, which can directly interact with your hardware and gives you the output. But
if you had to compare C and Python, how would you compare them? Let us know in the comments.
C, if you'll compare C with Python, so C is portable language. Okay, but C is not platform independent. Okay, whereas if you'll talk about Python, Python is portable and platform independent. Okay. So what do you mean by portable and platform independent? Remember, when you talk about portable, so if the source code can be moved from one platform to another, then we say that programming language is portable. It means the code which you have written here, Python source code, you can move from one platform to another, one system to another. Does not matter, it will execute everywhere. Actually, all the high-level programming languages are portable. Okay. But all the high-level programming languages are not platform independent. When you talk about the platform independent, so it means the intermediate code, right? If you are able to move the intermediate code from one platform to another, then that particular programming language is called the platform independent. Okay. Fine, everyone. So here in this case, if you talk about this bytecode, let's say if I will develop this bytecode on Mac, and if I'll give it to the Windows user, they will be able to run this bytecode as well. It's not only the OS, it's also about the different set of hardwares. Here.
Abhishek, you said C is portable and platform dependent?
Yes, yes.
Okay.
Okay, clear everyone? From one system to another, it may be different OS, it may be different set of hardwares, components. So when you are able to move, let's say it's not dependent. For example, you have i5 processor, Intel processor, and AMD processor, right? So if you're writing the code on the, let's say, on Intel processor, so this bytecode can run on AMD processor also, right? So that becomes the platform independent. In case of C, it is not possible.
Abhishek, I have one question here. So this platform dependency platform independency of Python, is it because of the virtual machine where this
virtual machine? Yes, it is because of the virtual machine.
Okay, okay.
So you install the environment to run this bytecode. Okay. So this virtual environment on which, so basically what happens in case of C, right? If you take the example of C, So in C, you have this source code, you have the compiler, and you creates the, this compiler creates the executable code, right? This executable code is actually equivalent to this executable code is equivalent to the machine code. Why we say machine code? Because this executable code can directly interact with the hardware. Hardware of your system. So machine code is what? Signals, right? 0, 1. These all are the signals. These signals interact with the hardware. They are getting passed into the motherboard, CPU, RAM, ROM, everywhere. And then these signals, when they are processed, it is giving you the output, right? So this executable code which created, it is actually very low level of code, and it can directly interact with, it can run directly on the hardware. Okay. So if you will run this executable code, so let's say if you have used Windows operating system with Intel processor and the, like with the set of same manufacturer, if you'll be having another computer, if you'll run that executable code on that platform, it will run. But if you'll run it on a different platform with the different set of hardwares and different operating system, it will not run. Right? So this executable code is not platform independent, it is platform dependent. Right? Why? Because it is directly running on your hardware, right? So, and hardware is going to be specific for a system, right? Whereas this you are installing the PVM. This bytecode is not running on your hardware. This bytecode is running on the PVM, and you are going to install PVM. So when you install Python, actually this Python gets installed. Okay, so it does not matter whether this bytecode was generated on Windows or Mac, it does not matter, or any other platform, it does not matter. You are giving this to PVM, and PVM understands this bytecode, right? Because this is the language which PVM can understand. Okay. Clear, everyone? Any question?
Nothing so far.
Sir, do we have a provision to run a .pyc as it is?
Yes.
How do we run it?
We'll see that. We'll see that in some time. So this part is clear. Portable and platform independent thing is clear, everyone.
Abhishek, sorry.
Yes,
So
If-
one more doubt. If PYC is it portable also, or is it again depend upon the underlying machine?
See, when you talk about portability, so you move the source code. When you talk about the bytecode, so it, like when you can move the bytecode from one platform to another, that language becomes the platform independent. A language can be a portable or platform independent, not the code which you are writing. Okay. Means you say that Python is portable or Python is platform independent. Okay. And when you say Python is portable, so by default, you'll understand that source code can be moved from one platform to another platform. And when you say Python is platform independent, it means bytecode can be moved from one platform to another platform.
Okay, thank you.
Okay. Yes. Anything else?
Abhishek, if you say that C is portable and platform independent, which you said the source code can be used, if it's a portable, source code can be used in any other machine.
Mm-hmm.
But in C, there is no intermediate code. So how can we say it's
This is
if it's
intermediate code.
but it's already directly interacting with the hardware, whereby
Yeah.
in platform
So
that
that's why
output
it's
will
not
do it.
platform independent. That's why C is not platform independent.
But we can use the source code in any machine, and with the compiler, it will work with any other, it will interact with all the hardware.
Yes.
So I'm not understanding this part. So how come it's platform dependent,
There
independent?
are
How
two
does
things.
its
There are two
parameter is coming into the context?
There are two things. when you can move the source code of any language from one platform to another. Listen to this, when the source code, this code, source code of C, source code of Python, source code of Java, when you can move these code from one platform to another, we say that language is portable language, right? So C source code can be moved, so it is portable, right?
Yeah.
Now this executable code is getting generated. This is an intermediate code.
Yes.
This gets generated.
Okay.
You will be able to see this file. This gets generated.
But it's not gonna interact with all the hardware because it's not
Yes.
platform independent. Okay.
Yes.
I got you.
We say it is platform dependent.
Right. Thanks.
Anything else, guys? Okay. So I hope you guys have understood this platform independent and the portability part. Now, why Python is called the interpreted language? Why Python is called the interpreted language? So we have compilers and interpreter both, right? So now, can anyone tell me that why do we need the interpreter? Why can't we just use the compiler just like this? We are using it into the C. Why do we need to move the intermediate code from one platform to another?
As we are not defining the variables like which is it int or float, interpreter does that because of that and allocates the memory.
Yes, memory allocation and type check.
Yeah.
Right. But that's fine. That's a different aspect. Okay. This intermediate code. So let's say if I define the Python, in Python I'll define the integer and all. So let's say we have the that provision where we can define the int type and all those types. So then we can have the compiler. So what problem you will face? Let's say what is the problem in the C? So that we have splitted this into the two parts. Like Java also, you will see there are two there are two compilers we are using, one compiler here and one JIT compiler here. In the initial days of Java, we used to use the interpreter also here. Okay, so this compilation step, why it is divided in two parts? Why can't we have only one level of translation? Because this is making your application slow, right? This will be faster.
But the virtual machine is the one which interacts with the hardware, right?
You remove this virtual. That's what I'm saying. You remove this. If this is creating the problem, remove this and have just one compiler which will do all these things for you. Then what problem you are?
If it is
Line by
platform,
line.
it will become platform dependent, right?
Then platform that. So what is the problem? C is also platform independent. Aren't we using C?
In the compiler, every output get by line. If there is mistake in the
compiler executes the whole code at once.
Yeah. So in the when we use the compiler, every in the source code, every step is getting like get the output in the intermediate code, and then final output we will get by interpreter.
Okay, I'll tell you. See,
It will help more in the collaboration side because it's platform independent. So people can work on different platforms, and there'll be this gives a chance of faster development since it opens the doors for people from different platforms and different hardwares to work together.
So that you are doing with the source code. What development you do in the bytecode? Actually, you are near to that, but you are just one step behind that.
So it means that if I can have different products and use the same executable to run the.
Exactly. Okay. So see, basically, when you develop a software, there are two things, right? There are two kind of people who are going to work on those software. One is the developer and one is the user, right? Developers and users, right? Okay. So now you guys tell me that you have the source code and the bytecode, okay? I'll give you one example. You have a C source code and you have a C exe code, okay? Correct? This is abc.c and this is abc.exe. Now think from the user point of view. When you download any software, what do you get? .exe or .c?
.exe.
EXE.
.exe.
Right?
EXE.
You get the intermediate code, right? Users always get the intermediate code, correct? When you are a developer, so you need the source code, right? Because you'll be developing the code, so you need to make the changes here. You'll need the source code.
Yes.
It means that in case of C, but the problem with the C is what? That let's say this code was developed on Windows, okay? So you need to have Windows, correct? You cannot have Mac. For Mac, this person has to compile it on Mac and then create the corresponding .dmg file for the Mac. Clear, everyone?
Yes.
Yeah.
Okay, so this is the problem. Now you understand what is the problem of the platform dependency in C. So let's say if different, like every system in the, like probably I'm using, let's say I'm using Windows, Intel, i5 and 4 GB RAM from one manufacturer, right? And you are using Windows, Intel, i5, 4 GB RAM from a different manufacturer. So what these developers have to do, that they have to consider all the corner cases where what all the different manufacturers set of possibilities, probability and permutation combination they have to do to find out that how many set of these intermediate files we need to launch a product into the market, right? So this will be a problem. So what do? We have made this platform independent. These languages, like after C, these languages are platform independent. Okay, and so this bytecode which has been created, so you install a virtual machine and you run that bytecode on that virtual machine. Okay, so it makes this particular language, the Python, as the platform dependent. Now you develop on any platform, does not matter. You create the bytecode on any platform, does not matter. Let's say you are the user, this was developed on Windows and you have a system called A, does not matter, it will execute everywhere. Clear? Fine, everyone?
Yes.
So you understand the use of splitting this compilation step in two stages? Any question, guys? Okay. So now let's come to the why Python is called the interpreted language. When you say Python is interpreted languages, there are two things. You will always see memory allocation and type checking. So it is done by the compiler. If it is done by the compiler, then we say it is the compiled language. Okay. And if it is done by the interpreter, we will say that it is interpreted language. Interpreted language, right? So we have seen one example yesterday only that, okay, so let me write a code first, okay? Okay, so we have seen one thing yesterday, that how does this compiler work? Can anyone tell me please? How does this compiler work?
Compiler will take entire source code at once and then executes it and then gives intermediate bytecode.
And how interpreter works?
Interpreter will take code line by line Once if any error is present in any step, it will stop executing from that step. Before error, it will give output for that steps.
Okay. So everywhere you will find that it is said to be Python is interpreted language. I say Python is compiled and interpreted both, but you don't see that how you can verify whether it is compiled and interpreted both or not, right? So let's say if I write the code A is equal to 10, B is equal to 20, is equal to A plus B and print C. When I'll execute, so this is the source code. When I'm executing it, I'm not able to see the bytecode. I'm not able to see the compilation, interpretation, all those things. I'm directly seeing the output. How I'll be able to identify whether interpretation is happening, whether compilation is happening, and you will find all the material related to that Python is interpreted language. So let's say if it is executing line by line, then where the compilation is happening, whether bytecode is at all getting generated or not, that we need to identify, right? So for that, we have seen like what we have discussed, compiler and interpreter. If so, in the case of compiler, if there is any error in the middle of the code, whether that code will be compiled?
No, it will not.
No, it won't be compiled, right? So it means that if it is only interpreted language, and if I'll make the mistake here, let's say if I'm writing print A, print B, and I'm going to make a mistake here, I'm just removing this. So if it is only interpreted programming language, then it should give me the output till this line. It should print the value of C at least, right? Line by line execution. If it is only interpreted, then it should give me the output for this.
Yes.
Right? Okay. And if it is compiled, first compiled and then interpreted, it means it will not give me the output because we have the error. This is the syntax error. So we have the error in this code, so it will stop the compilation, right? So execute it. We have got the syntax error. We are not getting the output over here for this line also. It means it got stopped at the compilation stage, right?
Yes.
Clear, everyone? Interpretation did not happen at all.
Yes.
Bytecode did not get generated. Okay.
That means compilation is itself not happening here because of the syntax error,
Yeah.
right?
Yes. So it is getting stopped at this place itself, at this stage. It didn't create the bytecode. That is what we discussed, right? Compiler will not work. Correct?
Yeah.
Okay. Okay. So what we have seen, see, basically we have seen here that if you have any compile time error, then compiler is not going to work and bytecode will not be generated. Since bytecode is not getting generated, so even this code output also we are not getting, though the output is correct till this line. And we have discussed in the case of interpreter, if the code is correct till this, it will execute it and then it will stop the execution here, right? Okay. Now, so syntax error you understand, right? Now let me tell you, like, let me know A is equal to, let me write this in.
Sir, can we say that this one is a true compilation? No, right? It is not a true compilation, right? It is a.
What do you mean by true compilation?
True compilation is in the say, in the case of C language, right? We will be getting an exe file, right?
See, the thing is, there is no specific definition of the compilation. Okay, so compiler you design based on your requirement. Compiler is just a software. You can tell your compiler that this task you have to do, right? So in case of C, you have defined that while developing the compiler in the case of C, that it has to check for the syntaxes, it has to check for the data types. Then accordingly, the memory allocation, all those things will be happening for the variables and all, right? So those all things are defined at the compiler level in C, and that is what it makes it complex, right? So here, what you are doing to the compiler, you are just assigning few tasks. You are saying you just checks the compile time error. Don't check for the runtime error. That is the task of the interpreter. If you have any runtime error in the source code, compiler will not check that. Apart from these two errors, it will not check any other error.
Okay, got it.
Okay.
Abhishek, in this case, then shouldn't Python be actually called both compiled and an interpreted language? Why are we only specifying it as an interpreted language? Because
That's
we
what
are
we
using both.
So we discussed, right? So interpreted language, we say because the task I said, memory allocation and type checking, that is done by the interpreter. So actually your code is getting executed by the interpreter here. The memory allocation is done by the interpreter of the PVM part.
Okay, understood.
Okay, at that stage. Okay.
Yeah.
Okay. In any language, you can check that. So any language, like in the case of Java, we say it is the compiled language, right? Initially, when we used to use in the beginning, can you please repeat it once? What you want me to repeat? Okay, I'll come to that. We'll discuss that again. So see this. This is the code I have written. Can anyone tell me what is the error in this code?
D is not defined.
D is not defined. But is there any syntax error in this code or indentation error in this code?
No.
No.
It means it is not a compiled line, compiled time error,
Yes.
right?
Yes, it is
It is not a
runtime.
compiled time error, it is a runtime error, right? Let's execute this.
Mm,
You'll see you are getting the output for print C and print A, right? 40 and 10. Clear, everyone?
Yes.
What does it mean?
Yes.
It means this was the runtime error. So compiler didn't check for the runtime error. It just created the bytecode with the runtime error. While executing the code, when interpreter started executing the code line by line, it executed till line number 5. And as soon as it found the line number 6, it saw that, this is the error. This is a runtime error, which was caught by the interpreter and stopped it. So even you didn't get the output for line number 7. This is what interpreter does.
Yes.
So, however, why did it only catch the syntax error? Because it is a compiler, is it?
Yes, this one, right?
Yeah.
Yeah, because of the compiler. Compiler checks the syntax error and indentation error.
Understood. Okay.
Clear, everyone? So what we can understand from these discussion, point number 1. If there is any error in source code, any compile time error in source code, then bytecode will not be generated. Thus, generated. Right? Point number 2. If there is any runtime error in source code, then bytecode will be generated, but interpreter will execute the code partially, right? Correct. This is what we have discussed here. Any questions? Okay. So now you want to see whether this compilation really happening or not, right? We have seen it with just we are assuming that, okay, compilation is happening, interpreter is happening. So we are going to compile the code and interpret the code manually, okay? So I have opened the terminal. You guys don't have to do anything. I'm going to write some commands, so most of you guys are aware of it. But yeah, so what I'm going to do, I'll just show you the step of compilation. So I'm going to compile the code. I'm going to then execute the compiled code. Okay. One thing. Second thing, what I'm going to do is I'll show you the compilation. After compilation, the bytecode which is getting generated. Okay. So it is getting saved. So I first need to move to the desktop folder. Right? Okay. So this is the desktop location. Now, are you able to see any file or any folder called PyCache folder? If you're able to see, please let me know. I don't think so it is available. Yeah, PyCache folder is not available. Now, what is this PyCache folder? So let's say I have created one file on the desktop, Python file. And if I'll be executing that Python file, so the bytecode which gets generated, that will be kept inside the PyCache folder. Okay, py cache, double underscore py cache, PyCache, double underscore. In that folder, it will be kept. Okay, so wherever you keep the file, Python file, in the same location, one PyCache folder will be created, and in that location, in that folder, the bytecode will be kept. So let me create a Python file. I'm going to write here vim f1.py. Sorry, let's move to the desktop. Okay, so currently I'm on the desktop, right, using the terminal. Now what I'm going to do, I'm going to create a Python file. So I'll be writing vim f1.py. You guys don't have to do anything. Don't do anything. Just understand. I've created a Python file using the terminal. I'm going to write the code. Okay. So let me know if there is any error in this code, right? So if you'll see f1.py is created, where it is created on the desktop. Okay. So you can see f1.py here. Just now it got created, right? What I'm going to do is, let me show you the content of f1.py. This is the content. Can anyone tell me, is there any error in this code?
No.
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 So if I will execute this code, so it is going to give me the output, right?
Yes.
So how you can execute the code from terminal? So there is a command python f1.py. Okay. When you will run this, it means you are going to execute the f1.python file using Python interpreter. So it gave me the output. Everything is fine. It means if your code is correct, there is no compile time error, bytecode will be created, and if there is no runtime error, then code will be executed completely, right? There is no error at all. But where is the compilation? Again, I just executed the code, I got the output, but where is the compilation? Where is the bytecode? PyCache got created. So remember, I told you that when you execute the Python file, all the intermediate steps are abstract. Okay, it is not visible to you. It happens internally, but you'll not be able to see that. Okay, it happens internally. Bytecode got created, it got loaded into the RAM, it sent the instructions to the CPU, it executed. These all codes given the output, and then that bytecode is removed. Okay. In case, so what I'm going to do, I want this bytecode. How I can see that bytecode? So if I want to see the bytecode, I'm going to write here Python -m py_compile f1.py. What is this code? It says that use the py_compile module to compile f1.py. I'm just going to compile the Python file. I'm not going to execute it. I'll just compile it. So if I'll press enter, I'm not getting any output. But if you will see here, one PyCache folder got generated. Correct? And if I'll open this, you will see that f1.c python -38.pyc, which got generated just now, 8:38 a.m. Right? What does it mean? Now, what is this? What is this bytecode? If you'll open, you'll not understand anything. But yeah, so it's just some encoded code. So you can ignore that. You'll not make any changes here. So we have got the bytecode, right, into the PyCache folder. This bytecode got generated that we have seen here, right? Next, what I'm going to do, I need to execute this bytecode. So first step is what? Compilation. I compiled the file, I created the bytecode. Now I'm going to execute this. Means I'm going to interpret it. So to interpret the code, first you need to move to that location where the bytecode is there. So I'll be moving to cd_pycache _. Now, if I'll do the ls, so I have this f1.c python -38.pyc. I'm currently into PyCache location on the desktop. To execute this bytecode, we have python f1.c python -38.pyc. So I'm now executing the bytecode. When I'll execute the bytecode, I'm getting the output. It means compilation happened. There was no compile time error. I didn't get any error. I executed the bytecode. There was no error. I got the output. Everything is fine. What if I'll I'll make some error into the source code. So let's do that.
-38 is the execution one, is it? Python f1.g -30.
This is the Python file. This bytecode. This is the whole bytecode.
Okay, that was there in the Python cache. Okay.
Okay. So vim f1.py. This is the Python file, right? And this is the code. What I'm going to do, I need to make some compile time error. So I'll be writing print A, print B, okay. And compile time error is syntax error. I have removed this bracket, correct? Escape :WQ. Let me delete this PyCache folder because this is for the previous file, right? Now, if I'll see here, I have f1.py, right? So I need to compile it. Let's compile it. Python -m py_compile. Let me show you first the f1.py. This is f1.py where bracket is missing. This is a compile time error. So Python -m py_compile f1.py. I'm compiling the Python file, this Python file, which has the syntax error. Execute it, and you are getting the syntax error. Did bytecode got generated when you have compiled? No. Right? Clear, everyone? It means if you have any compile time error in your code, code is not going to be executed. Compilation will not happen at all. First thing. Next, what we have, let's do some runtime error and then see whether the compilation is happening or not, right? So okay, so we have this runtime error, print D, right? This is not a compile error, this is a runtime error, correct? So let me show you the content. This is the content we have. So we have seen the content of f1.py, which is not having any compile time error, but it is having a runtime error. So let me compile this Python file. I'm going to compile the Python file. It didn't give me the error for the compilation, and PyCache folder also got generated here just now. If you'll open this, you'll see this is the f1.c Python, and this is generated at 8:43 AM just now. It means this particular bytecode is having the code for this print D also. Okay. It means if there is any runtime error, bytecode will be generated because compiler is not checking for the runtime error. Bytecode will be generated. Okay. Now, if you try to execute this bytecode, then it will give you the error. So bytecode got generated. It means compilation happened, though you were having the runtime error. Let's move to cd_pycache. This is the bytecode. I'm executing it and I'm getting the output for these two lines. And since this is the runtime error, so it is giving me this name error. It stopped the execution, right? Which is the interpretation part.
Yes, right.
Clear, everyone? Any question till here, guys?
No.
No. No.
So we have checked the compiler and interpreter, all these things happening into the Python. It is compiled and interpreted both, right? Okay. And so let me know if you guys have any questions.
So is it possible that we can have first interpretation, then compilation?
No, we have, like, Python is designed like that. For that, you have to make the changes into the configuration, or you have to design your own Python or your own language where you can do that.
Okay, okay.
But again, when you do the interpretation, You cannot do the compiling.
Okay.
Try to find out why, because we have discussed that reason already. Yes, Shiksha, do you have any question?
Yes, Abhishek, hi. Abhishek, can you please explain again why Python is called the interpreted language? Once again,
Python is called the interpreted language because the memory allocation and type checking is happening at runtime. Okay, so I'll tell you, I'll show you. So now you have understood this compilation interpretation. You understood one thing, that compilation and interpretation is happening, both are happening into Python, right?
Yes, yes.
Right? Okay. Now you have seen the bytecode, which is not in the human readable format. Let's see the bytecode which is into the human readable format. Okay.
Yes, okay.
So, like we can start at least. Okay. So what we have this f1.py. What I'm using a disassembler which assembles the code. Okay. So basically, it will give you the bytecode. This disassembler is going to give you the bytecode, but not into the format which we have seen just now. It is going to be into some other format, which at least something we can understand, some idea we can get out of that. Okay. What is the code here? A is equal to 10, B is equal to 20, C is equal to A plus B, print C, print A, print D, B. Okay, so what I said, this is the code we have right now, which we have disassembled, and we have got this bytecode. Now, this is line number 1, A equal to 10. What it is doing? So first it is loading the constant value 10. Okay. And then storing the name A. Means it is loading. So when you write A is equal to 10, first the value is loaded. So this is the instruction. Yesterday, you remember I told you that interpreter executes instruction by instruction. This is one instruction. So first this instruction will be given to the interpreter. So your interpreter will load 10 value first, and then that value will be assigned to A. Okay. Now, Python cannot, in any language, memory cannot be allocated until and unless your interpreter compiler knows that what kind of object it is. If you'll check the example of C code from yesterday or Java code, you declare int A. So in these languages, these all are called the static languages, where you define the data type for a variable which you are going to use. In this case, this is a valid statement. In case of C and Java, you don't need a value to be assigned here. You can just declare the type, and based on that, it will allocate the memory. Because compiler will check that what is the type of this variable, and based on that, it will allocate the memory, 2 byte, 4 byte, whatever it is. So this type is mandatory. Since this type will be checked by what? Compiler, in the case of C and Java. So compiler is going to check this type, and then it will allocate the memory for that, right? In Python, do you have any type? And does compiler checks the, apart from compile time error, does it does anything? Does it do anything? No.
No.
Right? So it just checks for the compile time error, syntax error and indentation error, right? So, and you don't have the data type. So how the memory will be allocated? So in case of Python, first, this is why the reason this is called the dynamically typed programming language. And in this case, first the value will be loaded, and then interpreter will decide that what is the type of this value. Based on that, it will allocate the memory.
Okay.
Clear,
Okay.
everyone?
Yes, Abhishek. Thank you so much.
Thank you. Disassemble actually is another way of compilation. Okay. You are doing obviously before the interpretation. Now this code will be given to the interpreter. Okay, Arif? This code will be given to the interpreter. Interpreter will first load the value 10, and then it will store it into A. Then it will load the value 20. Then it will store it into B. You will see that even for print D also this code is generated. This is what the bytecode. This bytecode is generated even for print D. But when you will give this, when interpreter will come to this line, when it will try to load name D, it is not defined. See, it is loading the name A also, it is loading the name C also. But when it will try to load name D, it will not be defined. It will give you the error. This is where it gives the error. The interpreter stops the execution. It is in PYC only. We are compiling the Python file to get this code. Okay. Clear, everyone? Any question?
Yeah.
Why do we have it like in the like multiples of 2? Why do we have the numbers like that?
These are some offset value you ignore as of now. For this, there are a lot of discussions will be required for this particular line and this particular line.
Okay.
You can ignore it. You just read the instructions,
Okay.
and you see these values, and you need these ones. Okay. For this, these all are the offset value. For that, different language itself is required. That is the assembly language you need to learn. If you are coming from EC background or computer science, you'll understand it. Otherwise, just ignore it.
Okay, thank you.
One question. So this disintegration is happening at compile stage or at integrations at the
This is
interpreter stage?
No, I told you this is the compiled code into the human readable format.
Okay.
This is the compiled code into the human readable format. Now this code will be given to the interpreter. So I wanted to show you that why it is called the interpreted language, because memory allocation, now when this code will be passed to the interpreter, this is the instruction which will be given to the interpreter. Interpreter will execute it and it will see it is a value 10. So it will identify that it is integer object, and then it will allocate the memory. So interpreter is doing that. Compiler is just giving that source code into this format, this instruction. Compiler is giving this instructions. Okay, that's it. This is the bytecode.
Okay, thank you.
Okay, it is not executing it. Interpreter is going to execute these instructions one by one.
So memory allocation is happening here, is it? When it says load constant.
Will happen after this. Memory allocation will happen after this. When it will be given, this code will be given to the bytecode. Okay, so let me do this. So you have this source code, right? You have this source code, and then you have the compiler. This compiler has generated this bytecode. Okay, and then this bytecode will be given to the interpreter, right? And then it will give you the output. So this interpreter will take one instruction at a time from here. So this code which you have seen, which I have just now shown, that compiler have generated it, and this code will be now given to the interpreter one by one, and it will execute the values and will execute the code. Clear?
Yes.
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 So this is not the execution. This is yet to execute. You told me that what is the bytecode now, right? So this is what the bytecode, which you can understand. Correct. Hope this part is clear for everyone.
Yeah.
Okay, so we'll take a break for 5 minutes and then we'll be back. Are you guys going for break?
Yes.
Yeah.
Just 5 minutes. We'll be back. So we have discussed about this. So
Abhishek sir, I have a question.
yes, please.
Yeah. So Python, you explained from the language that is a platform independent, right? So similarly, for C or the language that is not like platform dependent, how would that mechanism be? So if you could just compare this with that, maybe it would be more clear.
How that? How that? Sorry, I didn't get the last question. How that? How that?
Yeah, I mean to say that, like C and all of that is not platform independent, correct? So how would that mechanism be if we take the compile code of that C language? So what would the the whatever the final outcome? So what would that be?
Basically, what happens in C, the intermediate code which you generate in C, right? As I said, that it directly interacts with the hardware. It directly runs on your computer hardware. Okay. Correct. Fine. So when this is hardware dependent, it means it cannot run on another set of hardware, because this executable code which you have generated, it is specific to this set of hardware. It cannot run on other set of hardware. Clear? So it is not platform independent, whereas this bytecode which you are generating, it can run, it is not running on the hardware, it is running on the Python virtual machine. And this PVM will be installed on Mac or Linux or Windows, whatever system you have, whatever different set of hardware components you have. In that will be having some operating system, it will install the PVM, and your bytecode is going to run on that PVM. This PVM will understand the bytecode. This PVM is designed in such a way that it can understand the bytecode of Python easily. Okay, any bytecode generated on any system. So it becomes the platform dependent. It is not running on the hardware. Now, this interpreter, what it will do, it will generate the machine code. Okay, after executing this bytecode, that machine code will run on the hardware, and then it will give you the output. So the machine code which will be generated after interpreting the bytecode cannot be moved to the other platform. Clear, Fatima? Vijay, do you have any question? Okay. Is this clear?
Yeah.
Fatima.
Sorry, Abhishek sir, I just lost my audio. I had to just rejoin.
Okay. What I'm saying, that the executable code which you are generating in case of C, right? This executable code, it is specific to the hardware. It will be running on the hardware on which you have generated this executable code. You have a system, right? You have a specific configuration of the set of hardware, right? Hardware components. Correct. So this executable code which will be generated after compiling the source code, that will be running only on those set of hardware components. It will not run on the another set of hardware components. So basically, this executable code is directly interacting with your computer's hardware. Okay.
Right.
Okay.
So in that case,
Now,
if we run in a different machine, then it would not work, correct?
no, executable code will not work.
Okay.
Okay. Whereas in this case, Python, this bytecode is not running on the hardware, it is running on the PVM.
Oh,
now,
yeah.
a separate PVM which is designed for Linux, for Mac, not directly interacting with your hardware. It is running on the PVM. PVM is able to understand the bytecode. It will generate the platform specific machine code. That machine code will interact with hardware and give you the output.
Okay. Yeah, clear. Thank you.
Is my voice breaking?
Yes, it was.
Hello? Hello?
Yes, we can hear you now.
Yes, sir.
Fine.
Fine.
Okay. So now we have discussed about the all the concepts that we need in the introduction. So we'll just conclude this discussion about the Python. Okay. So Python, why we are using Python? First reason, Python is simple, easy to understand, expressive language. When you say expressive language, very few lines of code you will be writing. The syntaxes are not much complex, and you will be able to understand it. Okay, going forward, you will see that probably the code which, if you will be writing it in Java and C, which needs more than 100, 200 lines, that can be done in probably 10, 15, 20 lines maximum. The code which you need to write in other languages in 10 lines, 20 lines, you can do it in 1 line. And it is understandable. Anyone can understand it. Okay. So this is the first thing. Okay. Clear, everyone? Okay. The second point is Python is free and open source. We have not discussed this. Now we will discuss this. So what is free and open source? So whenever you talk about free, it means no license is required. When you installed Anaconda, did you purchase any license? When you installed Python, did you purchase? Like, you can see official website of Python is like Anaconda is the distribution of Python. Official website of Python is python.org. If you just want to use Python for the development purpose, you can go to python.org, go to downloads and download this from here. It is free of cost. You don't have to purchase any license. Yes, the enterprise edition, in the case of Java, you need to purchase the license, right? So that is not free. Okay, you need to purchase the license for that. Like Windows, not free. Mac, not free. These all are the softwares which are not free. You need to purchase the license, right? Python, you don't have to purchase any license. It is free of cost available. And when you say open source, it means source code is available freely. Okay. So can you get the source code of Java? No. Can you get the source when you download when you install Windows? Do you get the source code or do you get the exe file? You get the exe file. You don't get the source code. Okay. You cannot get the source code actually. So whereas in Python you have downloads. Click on source code, and when you click on this, you can download the source code of Python from here. You can download it from here. What is the code to develop Python? You can download it from here. So source code is freely available in Python. So it is open source, right? Okay. Third point is Python is portable and platform independent. Okay. Fourth point is Python is interpreted language. Okay. Fifth point is Python is dynamically typed language. Now, what is dynamically typed language?
No need to mention any data types.
Any data type, correct? So we didn't mention any data type for any variable here, right? Whereas in case of C and Java, these all are the statically typed programming language where you have to mention the data type. Python is dynamically typed programming language. Okay. Python supports almost all the paradigms. Whether you want to use scripting. So Python is a scripting language. Do the Python scripts. You can write the Python scripts. Okay. Python is the procedural programming language. Python is functional programming language. Python is modular programming language. And Python also supports object-oriented programming. Okay, almost all the paradigms. These all are the different paradigms. You take the different approach to solve a problem. There are languages which supports only modular, like Modular 3. There are programming languages which supports only functional. There are programming languages which supports only procedural. There are programming languages which supports procedural and scripting both. There are programming languages which supports procedural and functional both. There are programming languages which supports procedural, functional, modular, all. Okay, but if you see Python, you can use anything, you can use any approach. You can take any approach to solve a problem. These are the different ways of solving the problem. There's just a paradigm. Okay, fine. Point number 7. Python has huge library support and community support. Okay, so this is one of the biggest advantage of Python. Almost whatever you are going to learn in these upcoming classes, whether it be statistics, whether it be machine learning, deep learning, NLP, database, big data related packages, then deployment related packages, then you say the website development related packages. For everything, you have some package or library available in Python, and you can use them directly with minimal coding. If you want to develop a web application in Java, probably you need to learn minimum 5 to 7 or probably 10 different packages, or you can say the frameworks, including the core Java and advanced Java, HTML, CSS, JavaScript, Hibernate, Spring, all those things, right? In Python, if you have some basic understanding of HTML with less coding, you can learn Python and Django and you can develop a website. Okay, and whatever, let's say you want to do any mathematical analysis related to linear algebra, differentiation, calculus, or let's say the statistical analysis, for everything there are the packages. For like, you don't have to write the code from scratch. Like if you take C, probably you'll end up writing your 5 years, 10 years will go in developing those code and developing those packages and the frameworks for developing one algorithm or creating one model. Whereas in Python, those all packages and modules and libraries are available. You just import it and use it. The only thing you need to know that which package is used in which case, and in that package, what methods and what functions we have. I had out from the previous topic, that is the disassemble module. I would like to clear it at the end of the session. Is that okay? Since I have the microphone, I couldn't ask it out. So, okay, Arif, no issues. Okay. Okay. So this is the library support, and Python comes with batteries included. Now, what does it mean? You'll find this term everywhere. What is this batteries? So when you install Python, when you will be installing this Python comes by default with some built-in set of functions and modules. So see, for example, if you go to C, right? If you see C code, which we have written yesterday. So in that case, there was a hash include stdio.h, right? This one. What is this line? This is a header file. If you want to use the print function, scanf function, printf function, you need to include this header file first. Then only you can use them. Otherwise, you can't. Whereas in Python, the basic modules, the basic functions comes by default whenever you start Python. Okay, and where you can get it, if you want to check, you can go and check into the directory. You just write print dir of _, built-ins, _. You'll be able to see these all. You can see print function, len function. This is the print function. You can use power function, ord function, open function. These all functions, these all are some basic functions available. These all are the classes available. They are the, when you install Python, it comes with some basic module like math module, sys module, os module, random module, datetime module. There are different other packages which comes by default when you install Python. This is what called is that it comes with the batteries included. Some basic things it will become. Okay.
I have a question. How would we know, like, from which package has like arithmetic function or something? It will come by the time, like practice.
Yes, it will come by the practice, and when we will discuss the different code, when we will write the code, I will be importing the module, I will be using the packages and the other libraries. So you'll understand that this package I'm using for this. So for a mathematical operation, you have the math module, you import the math module, right? So when you'll be writing the code, we'll be using that. So you'll understand that. Okay. Clear, everyone? Any question till here? So I hope this part is clear. Okay. So next, what we are going to discuss about is the memory allocation and deallocation part. Okay. Memory allocation in Python. Remember, guys, any question till here?
No question.
Okay. Memory allocation in Python, remember, it is completely automatic. Okay. We as a user have no control in the memory allocation and deallocation part in Python. You don't have to bother about it. As a Python programmer, I'll be coming to this. Okay. One thing we have missed here, that why we are using Python for data, right? Why we are using Python for data science? Why not Java? Why not other languages? As I said, these reasons are more than enough to tell that why we are using Python. Out of that simple, easy to understand and expressive language, right? Think about, you have to write, you have to create a model, and you are doing just the coding, you are developing the package from past 4 years and 5 years. The number of packages which are developed in Python, if you start coding in C right now, it will take 2 to 3 years or 4 years, probably more than that, to create a model using C programming language. These packages are developed over time. Okay. In C also you can do that, but again, the function call and the importing and all those things will be so complex. Code is so complex, syntax is so complex, that probably those who are coming from non-programming background, it will be really a nightmare for, yes, we can import the custom libraries. It will be a nightmare to work in the data science field. And why the industry needs basically the people from the different fields. Okay, see, so we'll just go off the track here. We need to understand the use of Python, and also why everyone is learning, or why everyone has to learn the data science. Okay. One thing is clear. By looking at the market, it is quite clear that if you will not learn data science, or if you will not have the basic understanding of few technical things, you are in danger zone after a few years. Okay. First point. Why? So if you see, this Python. So those who are in 10th standard, they are learning Python. By the time they'll be graduated, at least they'll be having the basic knowledge of Python and the programming languages, right? In CBSE, it is included. So after 4 or 5 years, a different workforce will be ready who can come into the market and can start coding in Python. Okay, does not matter whether you are coming from commerce and all those backgrounds. So you remember, like, this Microsoft Office and all, when it started. So we were not having it, like, back in 90s and 95, we were not having the computers in our colleges and the schools, right? So now, after 2000 or 2005, those who are graduated, they have the basic understanding of Excel and all those things, correct? So now it is self-understood that anyone, even a simple person, knows about the Excel and he can work on the Excel. Similarly with the Python, this is same thing going to happen with Python. After 5 years, 10 years down the line, anyone in the market, even a simple person, will also be able to use Python. Okay, so Python is very important. Now, why Python is important? So let's say you are coming from, let's say I'm coming from sales background, okay, and I have to do a data analysis. So my data, as of now, still there are data scientists. Like, I personally know a lot of data scientists who are working for good companies, big organization, and still they have to work on the Excel and CSV files, and maximum they are working on the database. Companies are working, even the startups are working. So most of the startups are using the cloud technologies to store the data and to manage their database and all. So the infrastructure now is getting ready, which will be used in the future for doing this analysis and all. So even if you join a simple company, normal company, as a fresher, okay, startup also, so they will be having this whole infrastructure ready where you have to work using Python. So one thing is quite clear, that you have to learn Python. Okay. Second thing, that those all analysis, like when let's say, what is this stages? First of all, in the data science, you get the data, right? Getting the data first. Okay. And then when you get the data, you import it. For doing the analysis, you import the data to your local system. Okay. That is the second stage. After importing, you do the data cleaning. Okay, or not data cleaning, you will develop the understanding about the data. Okay, excuse me for this English and all those things I'm writing, but just understand the idea. Okay, you need to develop the understanding of the data. You have to look at the whole data and you have to come up with the story, or you have to come up with the the idea that how you are going to work on that data. What things you have in that data, what all columns are there, what all rows are there, and then the different parameters and the values which you are having, which is important for your project. So you'll be getting the problem statement also in the beginning, what business problem you are going to solve. Okay, and based on that, this data understanding you have to develop. Okay, once it is done, then you will start cleaning that data, because doing anything, first you have to do the data cleaning. Okay, once you do the data cleaning, once you are done with the data cleaning, then you will be coming to the data analysis, basic analysis. Okay, some basic analysis you'll be doing. You'll be trying to understand the data, the clean data again. Okay, that's what data you have. So when you do the data cleaning, that whole data is clean, like you don't have the missing values and the null values, and then you analyze the data. So this is the basic analysis. This is not going to be the detailed one. Okay, and after data analysis, you are going to understand the problem, what business problem you are doing. So you will be doing the statistical model, right? And then once it is done, then there are a lot of things, like you will be doing the feature engineering, right? Or you will be data imputation, right? These are all things you will do. Like there are multiple steps. Okay, and finally you will create the model. Okay, and after creating the model, you need to deploy the model. So starting from this point till the end, model deployment, everywhere Python will be used. You are getting the data. There is a concept of data engineering where we create the pipeline. We get the data from different sources, right? For example, take the example of the milk distribution system. So let's take the example of Maharashtra location. In Maharashtra, you have different villages, right? And then you have different units from where the milk is getting delivered to the different outlets. So before that milk is leaving those outlets, before those preparing milk is leaving that preparing unit, they are creating the data there, that how many milk packets are leaving the unit, and then where all location it will be going on. So that is the data. Then wherever it is getting delivered, they are getting the money, and everywhere now you have this digital system where the tracking can be easily done. Okay, so first of all, these data are coming from endpoints. You can think about a single user who is generating the data, and then that data you have to collect and give it to the organization. You have to create that pipeline which can collect that data. There Python will be used. Okay, once the data is into this system, as a data scientist, now your job will start. So this is the part of the data engineering. Here the data science part will start. You will start importing that data into your local system. For that you need the Python. You need to develop the understanding. You'll be doing some basic visualization and all. So you will be understanding the data. Some basic, we will do it in NumPy and Pandas. Okay, we will understand the data. Okay, how many null values we have. What if I'll remove all the null values? What if I'll not remove the null values? There are different types of things. Okay, so we'll be developing the data, understanding about the data. There you need Python. Data cleaning. Obviously, Python is required. Okay, then after this, data analysis. When you are going to do any analysis, you need the Python for that. Any kind of analysis. Then modeling, you need the Python. There are packages in Python for that. Okay, then feature engineering. These all things you will be doing with the Python. Model creation. There are machine learning algorithms which are developed in Python. You will be using them. And then finally deployment. Even if you want to deploy on GCP or AWS, so for that also you need Python. Probably the last stage will be the application development, like web application or mobile application. You have the Python also there. It means that every stage Python is required. So Python is very important. Now you can do it with C and Java also. The problem is in Java, they have started developing the packages now, and there are enough packages available, but the code is very complex. Now you write, you just see this code. Yesterday we have seen, you see this code to add 2 numbers, and you see this code to add 2 numbers. Now, anyone who is coming from non-programming background, you guys tell me that which code you would prefer to, code in.
Obviously, simple to understand Python is.
Right? So you are going. That's the reason we are using Python. Fine. So I hope this part is clear, that where Python is used, and Python is very important.
Yes.
Okay. So
Abhishek, Varun this side. Can you just give a brief about feature engineering? I just missed that.
Feature engineering, these all are the part you are going to learn. For example, you have some data, okay, and in that few columns, let's say, for example, you are working on a recommendation system, okay, of YouTube channel, correct? So the data which you are getting, probably most of the data will not be, or most of the columns will not be useful in your case. You need to draw a few columns. You need to create few columns out of that, right? So you engineer the data, like you do the feature engineering of the data. Okay.
Got it. Thanks.
Anything else? Okay, memory allocation. We'll start this topic tomorrow. Okay, I'll just give you a brief about that. I want you guys to go ahead with the notes which I have shared you guys. So we'll just discuss basic part. What is memory allocation? In memory allocation, so this part is clear, right? You guys have any question? Please let me know. In the memory allocation, we have 2 things. One is memory management, not allocation. Memory management, it is completely automatic. In this, we have memory allocation and deallocation. Just give me a minute, guys. I'm getting it. Okay, so in the memory alignment, one we have memory allocation, and the second one we have memory deallocation. Okay. Memory allocation. Here we have three tools. Raw memory allocator, object specific allocator, and Python virtual machine. Okay. And for memory deallocation, we have garbage collector. Okay, fine. And this all works automatically. These all things works automatically. They do the allocation and deallocation for you. You just have to focus on the code writing and the logic building. Rest all will be taken care by these tools internally. Okay, probably you don't need this in your day-to-day life, day-to-day coding in data science, but if you'll have this idea, at least you will be able to visualize that what you are doing and what your code is doing in the backend. Okay, then probably it will be easier for you to write any code. Okay, we'll learn about a tool also. I would request you guys to download this software, thorny.org, for tomorrow's class. Go here and click on this Windows or Mac or Linux, whatever operating system you have, download it and install this. Okay. Keep it ready for tomorrow's class. Yes, Arif, do you have any question? Guys, for today, I'll stop it here. You guys have any question? Please stay in the meeting.
Abhishek, tomorrow is Saturday. Would we have the class? And second thing, there was a discussion about GitHub. Yes, Git and GitHub. So would that happen tomorrow, or how do we go about it?
Hello.
Do we have class on weekends? No, right? It's
Hello.
only for
Guys, am I
weekdays.
audible?
Abhishek, can you hear me?
Yes.
Yeah,
we are going to do it on Sunday on Git and GitHub, not on Saturday. Saturday, I have another batch which is scheduled. So
okay.
Sunday will.
Okay, cool. So the next Python class would be on Monday, ideally.
Python class will be on Monday. Sunday, we will do the Git and GitHub. Okay.
Okay. And the link would be shared?
Link and timing both will be shared into the group.
Okay.
Abhishek, mainly pushing the code into the GitHub, that is the issue, pushing and pulling.
Yes, sir. We'll discuss that on Sunday. Exactly. Okay. Yes. Arif, do you have any questions?
Abhishek, can you explain indentation error?
Which indentation error?
Yeah, indentation, sorry. Yesterday I was doing some scripting, so I got this indentation error. So exactly I want to know.
10 b is equal to 20, c is equal to a plus b and print c. This is the code. Now, when you don't, like in this code, indentation is not required. Okay, why? Because you use the indentation to create a block. There are specific block making structures like if, elif, else, for, while, def, class. Yeah. These are the structure where you create the block. Here you don't need the block. So when you give a space or an indentation, it will give you the error. Okay, because it is out of the sequence. And so here indentation was not required. You have given the indentation, it is giving you the error. For example, let's say Friday is equal to 10, B is equal to 20. If A less than B, and then you need to print A. Okay, so here after if indentation is required, right? So when indentation is required and you are not giving the indentation, so it gives you the error.
Okay, so I was getting for the for loop. I was using for loop, and below that we need a tab space, and I did not take the tab space, so it was showing me the indentation error.
See, basically, if you'll be coding into the Jupyter notebook, and after for, let's say, for I range 5, okay, and here you after giving this column. So if you not give the column, it will go to the without this one. But if you put a column, like writing just the column in the Jupyter notebook understand that now your code is going to be, you need an indented block of code. It automatically gives the indentation.
Yeah, basically it suggests that we are entering into a block, right?
Yes, you are entering into a block. So you have to give this.
Okay, so I was wondering why this space is making me an showing an indentation error. Yeah, okay.
Sir, so for how many more classes are you going to do this theory and then move to practical, like coding?
Yeah. So Monday class, memory management. Tuesday class is about components, and we'll start with the basic data type. Wednesday class will be starting with the operators. Wednesday class, first assignment will be shared. And then with Thursday, we'll be starting with if, for, and everything. Don't worry, you guys enjoy it till Wednesday. After that, things will start, you feel that things are getting faster, but it will not go faster. I go with this similar pace, but the only problem is every day we start with a new topic. So it feels like, we are going fast. Anyway,
And the assignment will have whatever you're taught till now, all the theory things that you're taught till now, is it?
Sorry?
The assignment will have topics pertaining to what you've taught till now, right? All the
assignment, mainly it will be, assignment we have on the code, right? Coding assignment will be having.
Okay.
So after operators, the assignment which will be shared, it will be on integer, float, complex, boolean, and the things which we are discussing into the class. Apart from that, this theory part, for this, you will be having some practice set into the MCQ format. Okay, not as assignment, that is the practice set. So you guys can practice.
Okay, and we have to submit it by an email, or where we are on the portal?
1 week of time you will be getting.
Sorry?
1 week of time you will be getting.
Okay, and we submit it by email, is it?
Yes, by email.
Okay, thank you.
So for other classes like SQL and everything, the Zoom link will be different and it would be shared on LMS portal?
What classes you want to attend? So right now you have to complete Python. If you go to SQL, probably it will be difficult for you to understand. So first complete Python and then you can attend anything. Okay.
But the link would be the Zoom link would be different, no? And it would be shared on LMS portal.
For other batches or for your batches?
For our batches.
For this batch, it will be different. It will be shared into the LMS. It will be updated into the LMS.
Okay, thank you.
Anything else, guys?
Yeah, Abhishek, this is related to the Jupyter file. So it's like when I'm connecting with the local host 4 times 8, so I'm getting an error that the local host is getting refused to connect.
No, Gunika, you don't. 1 minute, Neha. Gunika, you don't have to select any option. You just go ahead with the default installation. Yes, Karthik, there is no class today. Firstly, I would like to know that this module is used to disassemble the compiled code. Is that right? Yes. Yes, Arif. Yes, Neha, can you please ask your question?
Yes, Abhishek. So basically, when I'm opening the Jupyter notebook, so I'm getting an error related to the local host. So it is showing the site can't be reached. Local host refused to connect. So I'm getting this error since yesterday. So before that, I was able to open Jupyter and I was able to,
See,
Yeah.
if you are using any third-party softwares or something like antivirus and all, first uninstall this. Okay. Second thing
Okay.
is if you have downloaded or used any extension in your Google Chrome, remove that and change your default browser setting to either Edge or you previously it was opening into the Google Chrome, right?
Yeah, Chrome.
Okay.
Yes.
So now probably you have to, what you need to do, like if you are using some antivirus and all, you just uninstall it. It would work. If it is not working, then change the default browser to something else. Okay. Why it is happening?
Okay.
There are some changes which has been done from your end into the Google Chrome or some software, something you have installed after that. Because of that, this is the problem you are facing. Okay, so change your default browser to something else and then don't install anything unless it is very much required. Installation means like, at least this antivirus and all, this is not required. Okay, don't use that.
Okay. All right. I'll
Windows
try that.
is already secure. So
Okay. Sure.
Is the class for today done?
huh?
Is the class for today done or any more concepts are going to be taught?
No, today's class is over.
Okay, thank you. Then I'll give you
some questions.
Abhishek sir, I have a doubt, very minor doubt.
1 minute, let me take the questions from the chat box. First one is Claire Mohammed, right? We use the source code file named f1.py with the compiler module to generate a bytecode file named in format.pyc. The file has been compiled. Yes, correct. Then we use the PVM to run the bytecode, the file in .pyc into PVM, and we get the desired output. Correct. Next question. So if there is any error on the runtime, we disassemble the compiled code in a human readable format to check for the error in the code. Am I right? No. See, when we compiled using for getting the .pyc file, right? So .pyc file was what? On the terminal. So see, forget about the disassembly. Okay. Compiler, you compiled the code, you generated the .pyc file and bytecode got generated. When I tried to open the bytecode using the normal format, like, the file format, default file format, it was giving something I was not able to understand, right? So to make you understand, I disassembled the code. Okay, that is also kind of compilation. I didn't compile the code. So it is just giving me the compiled code of the bytecode into the human readable format. It is not compiling the code. Disassembler is not compiling the code. Okay. Yes, on Sunday we have the extra class, Nishant. Rohit, I was informed that there will be 2-3 extra classes for folks with non-programming background. Would you be taking those? Can it be done before the assignment to ensure I am on the same page? Rohit, whatever we have discussed into the extra classes, right? This is what we are discussing. This is what we discuss into the extra classes also. Okay. So hope this part is clear for you. So if it is clear, then you don't need the extra class. So it is an additional option for our need. Yes. If you want to see the compiled code or the bytecode into the human readable format, you can go for disassembler. That's it. GitHub, no, Nishant, it's not about the GitHub. GitHub we are going to do on Sunday. The special class Rohit is asking for something else. So what does the .dis module takes into it? Either the .pyc, .py file. So Sunday and Saturday will be off day on usual case. Yes, usually it will be off, but this week Git and GitHub we need to discuss. So we'll be meeting on Sunday.
Please plan to do it in the morning if possible, then it would be fine.
Okay, no issues. We'll post the timing morning. Let me check my calendar. I'll ask the operation team to update it into your group. Okay, whenever it is.
Yes, sir. Abhishek, basically you are a Python Python tutor, or are you into a data science also? Just curious about it.
I used to work as a Python developer. I have never worked in data science, but I have the idea about it. So I keep on doing the research and learning. So that is the part of my interest.
Okay.
Sir, we need some extra classes for non-technical background basic. What is this? This is the basic information only we are discussing, Pawan. What is this thing? What other basic you need?
No, sir. In that we are using some extra codes. That's type of some codes we are using in that. In some examples, you are showing int this type of coding.
No, int and all, those all are just the examples in C, Java and all. So you ignore that. This is not required. Okay. See, the doubts you have, you can ask. Like, this is the C code. You don't need to learn about this. So you go through the videos. If you are from non-programming background, I will recommend one thing, that go through the videos and listen to the video. See, I understand what is the problem. Okay. When we are discussing about this, you are coming from non-technical background. This is the first time you are attending the programming classes. So you focus on the many things. Your mind is trying to catch most of the things, okay, at once, which is creating a havoc in your mind. So what you are going to do is, first you attend the classes. Whatever you are getting, don't try to get everything from the class. It is not possible. Try to get as much as you can, and probably you have to watch the video at one more time. Okay. I am not taking the weekend batches as of now. Otherwise, I would have asked you to join my weekend batches also, but you can join the other trainers batch on the weekend. Okay, that will be useful for you. So what you can do in that case, that whatever things we are discussing here, probably if same thing you are getting, then you will be able to understand 2 times when you will be attending the same thing, no? Or at least if you'll be watching the videos also, these things will be clear.
Okay.
Okay. And then if you have any doubts, you can book the doubt clearing session.
Okay.
Yes, Arif. Okay, guys, so I'll end this meeting.
And that's it for our introduction to Python. We hope you're feeling ready to take on the world of programming. Remember, the journey may be long, but with Python by your side, anything is possible. So, keep coding, and keep pushing the boundaries of what's possible. Yay, you did it! I'll see you guys soon with a new session, just for you. Stay tuned.